Welcome to the MSSQL Tips webcast. Protect your SQL Server data in the cloud. Sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MSSQL Tips and today's webcast host. Joining me today is Joey D'Antoni. Joey is a senior architect and SQL Server MVP with over a decade of experience working for both Fortune 500 and smaller firms. Also joining us is Dave Bermingham from SIOS, who is a cloud and data center management MVP. And today they will share their knowledge about protecting SQL Server in the cloud. Before we get started, if you have any questions, you can submit them at any time during the webcast. Answer your questions in the question area in your presentation controls, and we will answer as many questions as possible during today's webcast. If you have any technical issues with sound or screen quality, also use the question area to let us know. If you're not already a member of the MSSQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Joey, and he can get started.
Thanks, Greg. Today we're going to be talking about protecting your SQL Server data in the cloud and a few ways to avoid downtime. This is a cool topic. I really like working with the folks at SIOS and with the cloud in general. I feel like one of the really cool things about the cloud is that it makes disaster recovery and data protection a lot more available to smaller organizations that in the past might not have been able to take advantage of those sorts of things. One of the things that's always been kind of interesting is Microsoft has always recommended when you have a cluster split across sites, that you put your quorum disk in a third, or file share as the case may be, in a third data center. Most of the smaller organizations I worked with back when everything was on-prem were lucky if they had 2 data centers. That was probably 20% of them, and the number that had 3 was in the 1%. Now anybody can have 3 data centers. Microsoft has 34 locations across the world. Amazon has a very similar number, and it's very easy to build that complex DR to protect you. But a lot of people, when they deploy, especially initially when they get to the cloud, they don't necessarily think about these things. So we're going to talk about some ways that you can protect your data there. A little bit about myself. Like Greg mentioned, I've been doing this for a while. I'm a data platform MVP, and I'm a VMware vExpert. You can find me on Twitter at jdanton. You can find my blog at joeydantoni.com, and I wanted to pimp this article I wrote yesterday. So you can find that at bit.ly/SQL17. It's an article on all the new features that Microsoft introduced yesterday in SQL 2017, which has a name now, so we can actually call it something. So today's agenda, we're going to talk a little bit about the cloud, talk about some complexities and challenges that are there within the cloud, and how we connect, and how we can even build out hybrid solutions. We'll talk a little bit about how we can even bridge both clouds if we'd like to. We're going to talk about downtime in the cloud. It still happens. Things are a lot better in the cloud, especially if you're a smaller organization. Microsoft and Amazon run their data centers probably way better than you possibly can, just because of the resources and the technology they have involved with monitoring. But they still have downtime, and I'll talk about a couple of incidents that happened and some lessons learned that I've seen from companies with those sorts of cloud downtimes. Then we'll talk about some options for protecting your SQL servers in the cloud, and I'll give a summary. Dave will do a cool demo. So the cloud is not magic. I was doing a talk about DR in Belgium last week, because I was over there for a SQL Server conference. And one of the things that I think a lot of people, especially non-IT folks, and I'm talking about managers and folks who read articles and airline magazines about how great the cloud is, they think by just moving stuff to the cloud that suddenly there's nothing to worry about. Things like backups and disaster recovery aren't something you have to do. Depending on the nature of your cloud service, you may not have to worry about backups. So if you're using something like SQL database or Amazon RDS, you have the option to let them manage your backups for you. But most of the migrations we work on are our basic infrastructure as a service, or as we like to call them, lift and shift sort of projects, where we migrate a customer's on-prem infrastructure into Azure or AWS. And when we do that, you're still responsible for backups and disaster recovery and all that sort of thing. In some ways, you're a little bit more responsible for things because, like, a good example of this is when you're scoping a SQL Server design, you're also kind of responsible for your own storage architecture now, whereas before you might have had a SAN admin to rely on. So one of my friends in the MVP community, Argenis, works for a storage company, and they give out these stickers that say there is no cloud, it's just somebody else's computer. And that's kind of what the point I like to make here is that the cloud is awesome, and the cloud does a lot of good things for you, and you get all sorts of benefits like auto scale and you know, the cost components that we always like to talk about. But you still have to take care of things. So that's just something to be aware of. Outages do happen, and I'm going to specifically talk about an Amazon one here that happened a couple of months ago. But Azure occasionally has outages too. Actually, they had a not too dissimilar outage to this shortly thereafter. Amazon's, it was just not quite as broad. So what happened in March was Amazon has this key component called S3, which is kind of their low-end storage architecture that people use for a lot of hosting on websites. So they'll store a lot of files here. It's kind of become a backbone of modern cloud architecture for a lot of applications. S3 went down in the east region. So a lot of Amazon's customers have all of their data in the east region. This is probably the worst thing you can do in terms of cloud architecture, is to have all of your information in a single region with a single provider. Generally speaking, I don't like to recommend architectures where you span, say, AWS to Azure, because that tends to be pretty fragile. You can do it, it's possible, but it's not something I'd recommend. But always, always, you want your critical data to be across at least two regions in your cloud provider. Most of the time we see these failures, they aren't universal. They tend to occur in one region. The worst part of what happened with Amazon here was the images that were used to store this dashboard, which is the dashboard from the day the outage happened, were actually only in the East region. So the dashboard fully reflected that everything was healthy, so everything was green. They did put a text box on the top to say that we've identified a problem with their infrastructure, and they were able to isolate that. But the dashboard still showed everything is operating normally. So kind of an interesting scenario. And there were kind of lessons learned for everyone in these outages, as there always are when you have downtime. One of which was Amazon was deploying an update to the code to basically, actually they weren't deploying an update, they were trying to deprecate some servers. And in writing the automation code to do that, they accidentally took down more servers than they intended to. So only a portion of the servers running the service were up, and there wasn't enough service healing to bring them back. So Amazon learned some lessons, and their customers learned some expensive lessons. So my tip there is always be across a region for your critical services, not just for weather emergencies, but really for software emergencies that can happen. The other thing I'd say, especially for web applications, and I know we're talking about databases, is if you have customer-facing web stuff, I'd always make sure you have something available, a second provider, even if it's a static page, just because you in the event of a failure, of a provider-wide failure, you want to be able to have something so your customers can at least see something, even if it's a static page. The outage that Microsoft had, it wasn't as bad because it was only poorly, highly degraded service, which meant like new things couldn't get created, but it was across all of Azure, except for GovCloud and Germany, which are kind of two unique things. So we have a couple of poll questions to make sure you're staying awake. And the first one is, what percentage of your workloads are in the cloud? And you can answer this based on maybe, where you are now or what you're anticipating. And Greg will put up that poll in a second.
Okay, the poll has been launched, so give everybody a chance to vote on this. All right, get a good amount of people voted already. Let's just give this like another 10 seconds and I'll close this vote and share the results. All right, I'm going to close this. And I'll share the results. So we have 85% said 0 to 25%, 9% 25 to 50%, 4% 75 to 100, and 2% 50 to 75. So majority is 0 to 25.
Yeah, okay, cool. So a lot of you are pretty new to the cloud. That's good. So the first thing I always like to talk about is cloud security, because this is, in my consulting experience, this is probably the biggest hurdle in organizations moving to the cloud, is that folks are paranoid about their security because they're not hosting things. My all-time favorite story was this customer, very small shop, had servers on-prem. They're like, we can't move to the cloud because of security. And then the CTO/DBA/exchange admin, who is all one person, walked me to their server room, which was connected to his office through an unlocked door, and had no fire suppression. Microsoft and Amazon are really good at building data centers. They're really good at monitoring data centers. They've got just about every security audit pass you can think of, and if they haven't, they're probably working on it. I just saw today an article about Azure passing a new level of Department of Defense certification. However, security is still a concern. There are some things that are easier. It's very easy to make sure your disks are encrypted, which is a good measure of security. But it's also very easy to do stupid things. Even I know Microsoft has done dumb things. One of the things Microsoft did is one of the advantages we have in the cloud is we can take advantage of templates, right? So if we want, say, a SQL 2016 Enterprise Edition server, that's an option we can select when we're building our box in Azure or AWS with their machine gallery. We can build those servers, but what Microsoft did was when you built a SQL server in the template, and this is no longer the case, it was like this about a year and a half ago, automatically port 1433 was exposed to the internet on your public IP address. If you've never exposed port 1433 to the internet on a SQL server, I don't recommend ever doing this on one of your production workloads, but if you want to play around, you'll certainly see lots of failed SA login attempts into your error log. And they'll come from IP addresses, which if you want to take a little time to get an IP database, you'll see from all over exotic locations all over the world. Usually a lot from Russia and China, but many from California and those sorts of things. So don't open ports to the internet that you don't need. So one of the things you want to do, you have a great physical backbone of security. So all the tools are in place to give you security. Like I mentioned, encrypting your disk is as easy as flipping a switch to say your disks are encrypted. But you want to make sure your implementation is secure. You want to limit the public ports that are accessible on your network. And it's fairly easy to take advantage of access control lists if you do have any public ports that need to be open, you can limit them to an IP range in question. All the tools are there, but you can also do really stupid things. So take advantage of your VPN connectivity and build a secure cloud environment. So one of the ways we can connect Azure, and this is probably the most common way at most of my clients, is using what's known as a site-to-site VPN. Amazon has a very similar concept. In this case, we have, whether it's your data center or colo, a VPN appliance that's on the other side of the firewall from our SQL servers and our domain controllers and the rest of our network. And then we're going to create what's known as a network gateway in Azure. So this is a public IP address. And from our on-prem site to Azure, we'll have a direct connection. Frankly, when you have a VPN in place, and this really applies to Amazon or Azure, that second data center is really just an extension of your data center. There's no way, if you didn't have access to the portal to know which servers were where, there's really no difference and no way of knowing which server is where. So you may even consider, tagging in your server naming standard, tagging the cloud that they're in, just so you know that it's a cloud server. A couple ways you can do this. You can use either a VPN appliance from, you pick your network vendor, Cisco, Fortinet, any of those guys. Or you can use a Windows server using routing and remote access services. And that starts at Windows Server 2012, I think is supported for this, but you can also use R2 or 16. This is good for your basic hybrid connection. So if you just want to maybe, extend your cluster into the cloud, site-to-site VPN for one or two workloads is definitely suitable. It does route you over the public internet. It's a secure connection, but it's your basic VPN. So even though it's encrypted, you're subject to all the hops you'd have to go over to get to Azure. The next level of this is ExpressRoute on the Microsoft side. And this is significantly more expensive, but on the low end, it's not terrible in terms of cost. But this is basically a dedicated MPLS connection or provider connection, depending on how you have it configured. That's going to hook you directly into Azure. This can get really expensive. There are some advanced features, and if you're buying a ton of bandwidth and you need all the data to move back and forth, but if you're not a huge enterprise that's moving a ton of data back and forth between the cloud and on-prem, that shouldn't be a problem. One thing you'll note too about all cloud services, nearly universally, it's always free to get data in, and it always costs to pull data out in terms of network cost or even data cost to an extent. So Amazon has a very similar concept where we have a VPC connection. There's a gateway IP address, and then you just have your public IP on your ASA device, and that hooks into your network. They have a very similar connection, direct connection option, where you can have a direct connect from your own site over Ethernet to their direct connect site and then to the region. So those are aggregate connections. And the one other thing I'll mention is that it's important to note that if you're looking for a dedicated network connection, to know that those aren't available everywhere. Sometimes they're limited to cities, so you may have to, your last mile may be a challenge, but that's just something to be aware of. So our next poll, do you have DR for your cloud environment? And this one's a pretty simple yes or no, and a lot of you don't have cloud, so I'm just going to say, do you have DR for your environment? So you can answer the question that way.
Okay, the poll has been launched. Got a good amount of people already voted, so just give us another 5 seconds or so, and we'll close this and share the results. So far, the results are pretty close. All right, I'm going to close this down. And we have 57% said no, and 43% said yes.
Cool. So 60% of you don't have DR. So, man, I wonder how your companies sleep at night. But anyway, first thing I wanted to talk about was a little bit of Azure data protection, and this is just things to be aware of as a cloud concept. Azure has this concept of availability sets, and this used to be a good bit more complicated than it is. It's kind of more straightforward now in the modern version of Azure that we like to call RM, Resource Manager. And this is, we like to think of this as host affinity or anti-affinity for Azure. Just like if you had a cluster that you're running on a VM environment, one of the things you would never want to happen with that virtual cluster is for both of your cluster VMs to be running on the same physical host, because then you're down to a single point of failure, and why even bother having high availability, right? So we have the same concept in Azure, but it's called an availability set. And each virtual machine in your availability set is assigned an update domain and a fault domain by the underlying platform. And these two concepts, update domains are just like any other Windows server in the world. Azure has to do Windows updates to update the code, the underlying code on the physical machines that are running your virtual environment. Because as much as Microsoft likes to talk about how great Azure is, it's really just a giant Hyper-V farm with a bunch of really cool stuff built on top of it. So everything is effectively a VM at the end of the day. But these update domains protect your VMs when host updates. So what this means is that once your two VMs are in an update domain, when Microsoft's doing updates, those two VMs will never be in the same place where Microsoft's doing updates. Then there's also this concept of fault domains. Fault domains are just protection across single points of failure in Microsoft's infrastructure. So this basically what this means, and it's probably an overly complex way of explaining this, but you want to put machines that you don't want to fail together in an availability set. So your cluster nodes, your web servers, if you want all those things to be not on hardware, like not having a single point of failure, that's where you use an availability set. So it's a pretty basic concept, but that's part of probably the first part of your high availability design. One other thing I'll mention that's just a little bit of a quirk of Azure, that as you're building these, when you're building, you have to build your first machine in the availability set, even though there's no concept of high availability for a single machine. You can't add it in after the fact. That may get fixed later, but it's a little bit of a quirk now. The other concept that I really like, and this is a relatively new concept in Azure, or at least in the last year or so, is this concept of resource groups. And this is a pretty complex thing. I mean, I could probably talk about a couple of hours on how and why to use resource groups. But everything now in Azure belongs to a resource group. So anything you create belongs to a resource. We have these dependencies that are built in. So when we create a VM, we have things like network cards and storage and IP addresses that become dependent on the VM. And we have types of resources that are defined by resource providers. We also have role-based access control. So one of the key things to resource groups is they become your security boundary within Azure. In very early Azure, it was very challenging to do security well. You kind of were either a co-administrator, which meant you could do everything, or you had very limited rights as to what you could do. Now, with resource groups, we can get much more granular and assign access at either the resource level or the resource group level. These also lead to better templates. So we have a more consistent template model. And one of the really cool things Microsoft's done in the Azure portal is give you the ability to just copy the deployment code. So you can maybe build something once in the GUI and then copy the deployment code if you want to build it other places. So this concept of being able to do model deployment is really good if you're a company that's like selling a solution. So you can quickly sell a solution and deploy it multiple times for multiple customers. I know from my perspective, as somebody who gives cloud demos a lot, it's really easy for me because one of the things you can do is just delete an entire resource group. So if I'm giving a talk at a conference or building a lab, I might spin up a new resource group and put all of my resources that I need for that specific event in that resource group. And then when I'm done, I can simply blow it away. So this is kind of I didn't set up a poll question for this, and I suppose I should have, but this is kind of a way of grouping resources. And the question here is, should these resources be in the same group where we have a resource group, a web, a database server, with a database VM rather, and some storage in one group, or should they be in multiple groups? And the answer to this question is, do they have a common lifecycle and management? And the answer is, it's up to you. So it really depends on how you want to use the resource group. The example I always like to refer to with this particular slide is with the top resource group, if you're in maybe a DevOps shop where everybody's involved in managing everything, that might be the way you want to do it. In the bottom option where everything's split up, if you had maybe a web dev team, they might have the web and database. The virtual machine group might be managed by, a Windows Server team, and then storage might be managed by a dedicated infrastructure team. It just depends. There's no real right or wrong way to create your resource groups. Well, I guess there's a wrong way. If you just threw everything into a single resource group, that would probably be bad. But resource groups give you a lot more flexibility, and they're all about management. Resource groups don't have anything to do with performance or uptime or anything like that. It's all about just making your cloud management easier. So one of the things we run into is failover clustering in the cloud. So Azure nor Amazon necessarily have an easy concept for shared storage. So that limits our high availability options to basically availability groups for anything with real-time failover. Or you can do traditional things like log shipping where you have like a higher level of downtime. But the nice thing about failover cluster instances is they protect the operating system from operating system failure. And from a SQL Server perspective, their management's a lot easier than availability groups. So especially on a really busy server, availability groups can be kind of painful to manage, especially below SQL Server 2016, where they fixed a lot of things. So clustering in the cloud is a little bit challenging, and Dave's going to talk about this, and we'll talk about this more in some forthcoming slides. So next poll question, I thought this was a good one. Have you run into budget challenges when trying to do DR?
All right, it's been launched.
And I'm going to be shocked if the yes percentage is lower than like 80.
All right, good amount of people voted already. Just give it another 10 seconds here. We'll wrap this one up. And we get those final votes in. All right, close that and share this. So
okay.
yeah, 75% yes and 25% said no.
Yeah, so I'm surprised that 25% of you have had no budget challenges with DR. Pretty much from the start of my career as a DBA, whenever we brought up DR, it was a bit of a challenge because, frankly, it doesn't appear to be a value add for the business. So the most common solutions we see are always on availability groups in the cloud anyway. That's kind of the Microsoft recommended standard. These are introduced in standard edition now, but the standard edition model is pretty limited. You can only use a database at a time. And like I mentioned, there are a lot of management challenges around AGs. For example, jobs and users have to be manually handled. So that can be problematic. There's also a lot of, with a cluster, you just kind of run it like you would a standalone instance. There's things you really have to think about with AGs. You can do log shipping across the cloud, and I'm always a big advocate of log shipping. But frankly, it doesn't allow automated failover. It's something you have to configure at a database level. Or finally, the third option is downtime. So we see that with a lot of customers where they just don't really do anything until they have a big downtime scenario where something bad happens and then they're down for a couple of days or less, and then they look at it. Then those DR budget problems go away. My favorite DR story, and it happened to me while I was on call as a DBA. I got paged that a database server was down, and I logged in and I couldn't see any drives, and I couldn't figure out what was going on. So I called my boss, and it turned out our SAN vendor had come in to decommission a SAN, but they took the wrong one. So even though we had clustering and all sorts of things like that, our single SAN was a single point of failure, which is always a problem. So what Datakeeper does, and this is kind of a cool piece of technology that SIOS has, is it allows you to send storage from one site to another. So This lets you build a SAN or build a failover cluster without a SAN. Excuse me. And so this is some software that they have. So this works seamlessly with SQL Server. So you can configure redundant SQL Server instances in separate cloud regions. And when the failover occurs, it's just the same thing as a standard Windows Server failover cluster. You're not doing anything special. It's a standard SQL clustered failover instance. And it's a very, very straightforward implementation. The nice thing about this is you can easily span cloud regions, because what's going on behind the scenes is Datakeeper is sending your data across the network. And from a latency perspective, one thing I'll add is both Microsoft and Amazon have very good network capacity between their data centers. So if you're going multiple cloud data centers, that's a really nice option, and you're going to see pretty low latency. So your failover should be pretty seamless. So the other benefit of this, and this was something that was introduced in SQL Server 2012, is the ability to do multi-subnet failover clustering. Like I mentioned earlier, most of the failures we see amongst cloud providers have been limited to a single data center or region. That's actually one kind of nice bit of nomenclature I should mention there. Whenever you hear, especially Microsoft, talking about locations, they'll always say regions. And regions are the high level. So, for example, U.S. East is a region. But you may also hear them say data center. And when they say data center, they refer to individual data centers within the region. So every region has multiple data centers within it. They're at the same physical location, but the data center refers to a building. Spanning, one of the other things is I think there's like a 3.9 uptime guarantee at Microsoft. If you're in a single data center, they guarantee 3.9, as I recall. Dave, jump in and correct me on that if I'm wrong. But you can extend that to 99.99, so a whole nother 9, by just putting a resource in another data center. So with the multi-subnet failover clusters, like I mentioned, this was introduced in SQL Server 2012. It does require Enterprise Edition licensing, which can be a little bit problematic because, as we all know, Enterprise Edition, roughly $7,000 a core versus the much lower cost of Standard Edition. So the solution we can implement with SIOS is to enable failover of SQL Server Standard Edition across Azure Fault or Azure Fault resources or AWS availability sets in different subnets. So you can do this using Sandless Cluster. This gives you protection for your entire application environment, including the applications and the databases, and manage failover to a standby server. So this is a very nice way to do this. Basically, you're using storage replication to kind of fake out the clustering angle. So a very nice model. So one of my favorite options for high availability when we're talking about the cloud is to take advantage of this hybrid model. I know a lot of you didn't have any workloads in the cloud yet, and one of the things I really like to see customers get their start with the cloud is to look at doing disaster recovery there, right? Because you have one data center in most cases, and you don't have any protection if there's a, I grew up in New Orleans, so I always think of hurricane, but earthquake, tornado, you name it, any sort of natural disaster, or even more realistically, a major regional power outage. But it's very, very expensive to build a second data center. You have to, build a building, then you have to staff it with people, and then you have to fill it with computers. So that's not always a great angle. If you're on a colo, it can be a little bit cheaper because you just have to pay for more space. But using this hybrid cloud model is really fantastic, and Datakeeper makes this quite easy to extend your clusters to the cloud. So the nice things about extending these clusters are you get this remote recovery site for full DR protection. It's very easy from a SQL Server perspective to do, so it's really no different than building a cluster. The one bit of challenge that's there is really building your network, right? So once you have that VPN in place, then you can just talk directly to Azure and it's part of, or AWS, and it's part of your network. This also gives you flexibility, and it's also really cost effective. One solution I've seen customers do, and this actually works pretty well with a failover cluster, it doesn't quite work as well with availability groups, and I'll explain why in a second, is you can have a pretty small server running in the cloud for your DR, right? So in the event of a failure on-prem and you have to do your failover, you may have a server that's way smaller than your on-prem server, and when you fail over, then you simply resize the server upon failover. So most of the time, you're not paying for a really big server to power your application. But in the event of a failover, you can quickly increase the size, and that's one of the ways you can really take advantage of the cloud. The challenge with doing that with something like always-on availability groups in a hybrid fashion is that just to keep up with the log writes, because remember, all our writes are taking place through SQL Server, you have to have a reasonably big server, otherwise your log writes will fall behind. Since what Datakeeper is doing happens at such a low level on the SAN, or not on the SAN, on the storage, the writes are a little bit more efficient, easier to go with. And here we kind of see that model where we have the cloud and we have our on-prem, and then we have failover to the cloud. So this is a pretty nice scenario for a lot of customers that I've seen. It's something I've worked with Microsoft on for a while. I actually built one of the first hybrid clusters way back in 2013. So the technology is actually pretty robust to do this now. It's much easier than it used to be. There was some funny things you used to have to do that you no longer do. And things are even a little bit easier in terms of quorum now. One of the things that was recently introduced in Windows Server 2016 is the ability to have a cloud volume as our quorum device. So that makes it a little bit easier because traditionally that was one of the bigger challenges we had in these hybrid environments, was where do we put the quorum volume. But here, the way this works, we have Datakeeper on our database server. We have on the storage, we have replication that's going to go to our cloud volume. So the way that works is there's a filter driver that's a driver at a very low level that's going to send all the blocks get written to our volume to another volume that's running on a virtual machine in the cloud. So before I hand off to Dave, I just wanted to talk about a few things. Data protection still matters in the cloud. This is probably the biggest takeaway I want you to have. There are many ways you can protect your data, but you always need to be thinking about protecting your data. So you need to make sure you have your good backups. You need to make sure you have secondary servers available. It's generally speaking cheaper and easier to do this in the cloud. One of the things I do giggle at sometimes is people talking about how much cheaper the cloud is, and overall, there are places you can save money in the cloud, and disaster recovery is definitely one of them where it's way cheaper. But overall, the cloud is probably just as costly as doing things on-prem. But things like disaster recovery and long-term storage are really way cheaper in the cloud, and that's one thing I can't argue with. Failover clustering is still one of my favorite technologies. It's whole database protection with very little management for the DBA. You don't have to do much. Once your cluster's up and running, it's really straightforward. You have high availability without thinking about it. Availability groups are a really cool feature, but I still, from time to time, have problems with it, just from a keeping up with writes perspective, and there's some other weirdness with how it works with clustering. So it's definitely a feature that requires more hand-holding and is a little bit more challenging. Failover cluster instances just work. There's even support for failover clustering in Linux now. in SQL 2017, which is quite interesting. It's not as robust, I would say, as Windows Server Failover Cluster is, but it's available. And then finally, Datakeeper can help you protect your data. So one of the challenges in the cloud is that shared storage isn't really a thing. So how do we go about doing that? And Datakeeper allows us to do that by replicating our storage and making what is standalone storage shared. It can do the same thing in a virtual environment. So if you're using VMware, it becomes really painful to build clusters in VMware without using what's known as raw map devices, which your VMware admin won't want to give you. Datakeeper can do the same data protection in a VM environment, just like the cloud. So I'm going to hand off to Dave, and Dave's going to show a pretty cool demo.
Great, thanks, Joey. All right, so I'm going to share my screen here. And let's have a couple of quick slides up front and jump over into my live demo here to show you what Joey was telling you about. So SIOS Datakeeper enables what we call Sandless Clusters. So if you know, traditional clusters kind of look like this, 2 or more nodes connected to shared storage. When you start talking about cloud deployments, the shared storage is really the limiting factor. It's not available in the cloud. So what Datakeeper will enable, the Sandless Cluster will let you attach local storage to each node, and then we'll do block level synchronous replication between nodes within the same region, or if you want to have a multi-region failover, you can have asynchronous replication, which will let you replicate much further distances across higher latency connections. And then it integrates with failover clustering through a cluster resource called a Datakeeper volume, which we'll see in the demo. But after you configure it, it really behaves just like a regular cluster. So if there's a failure of one node, then one of the remaining nodes will come online and continue to function. And all that happens automatically, just like a regular cluster, because it is a regular cluster. And you can have multiple targets. So this configuration shows 2 nodes doing synchronous replication locally with local failover, and then replicating remotely to a 3rd node for disaster recovery. So that's another possible configuration. And Joey mentioned doing the hybrid cluster, hybrid cloud, where you might want to leverage the cloud as a disaster recovery site. And so Datakeeper can work in this configuration as well, where you do have shared storage locally, and you still want to continue leveraging that. And let's see, why did that just happen? 1 second, here we go. So you can have failover locally, and then you can replicate your SAN to the cloud or to your own data center and have disaster recovery configuration as well using the Datakeeper solution. So in the cloud, it kind of looks like this. This is a typical EC2 configuration where if you just want failover within the same region, you configure 2 nodes in different availability zones and have a file share witness in the 3rd availability zone, or if you're on Windows 2016, you can leverage Cloud Witness. But it behaves exactly the same as on-prem cluster, just configured in EC2. Azure, it looks almost identical. It would just call it different things. So instead of availability zones, we have fault domains, and you're going to have the same type of failover and high availability within the cloud instance. So let me jump over to the demo here and give you an idea of how this works. So as I mentioned, it really enables what we call Sandless Failover Cluster. So failover clustering is the mechanism that we're using for the clustering component. We're really, you can think of Datakeeper as a storage solution for failover clustering that allows you to leverage local attached storage. And we've been doing this for quite some time. SIOS has been around since 1999. This product that integrates with failover clustering was introduced when Windows Server 2008 came out. And so again, it's been around for quite some time. So as you see in this cluster, we have 2 nodes, SIOS 1 and SIOS 2 in the cluster. I have some roles pre-configured. These look like your standard roles at the SQL Server cluster. As you notice, it has a name and an IP address, the SQL resources, SQL Server, SQL Server agent. Here's where it's, you might notice a slight difference. Under storage, you see something called a Datakeeper volume instead of a physical disk resource. So if we take a look at this, the properties of this volume, we can get some information about the replication right from Failover Cluster Manager. We can see that it is synchronous. It's currently in a mirroring state. We can see the volume that's replicating the network that's using for replication traffic. The current source, SIOS 2, replicating to SIOS 1, and that makes sense because it's online on SIOS 2, and all that through Failover Cluster Manager. And so what I want to do now is take you through the process to show you how we kind of get to this point. The Datakeeper interface is a simple MMC snap-in that you can run on either cluster node or even on your local workstation to connect remotely. And you can see I have some jobs pre-configured. Here's the S drive we were just looking at. You see it's online on SIOS 2. It's replicating to SIOS 1. And this is the other one that was in there for the file server. So what I want to do is show you, we're going to actually replicate the R drive. And this R drive is just a local attached disk on each node has another R drive attached to it. So we're going to go ahead and create a new job. It's a very simple process. You give it a name, and then this three-step wizard. Choose the source system, SIOS 1. Choose the network you want to use for the replication traffic. Choose the volume you want to replicate, and then click Next. Then you choose the target server. SIOS 2 is the target. The network looks good. The volume looks good. And then here are your options. So for a local target, synchronous would be it. I would click Done. If I want to replicate greater distance, then I might choose asynchronous. I can enable some compression. This will compress the data before it's sent and decompress it when it's received. That's going to help save on bandwidth consumption. And if you're replicating out of the cloud, as Joey mentioned, getting data out of the cloud always costs money. So you can save money by compressing it before you send it out. And you can also specify a maximum bandwidth if you want to control, have some quality of service, make sure Datakeeper doesn't exceed a certain amount of bandwidth, so you allocate some bandwidth for other applications. You can do that right through the application. But for a local target, synchronous is all you need to choose, and we'll click Done. That initiates the replication of the R drive from the source to the target. And because this is a cluster, we'll get this pop-up in a moment that asks us if we want to register this in the cluster. I'll say yes, go ahead, register that R drive in the cluster. And now when I go back to Failover Cluster Manager, if I look at my storage, I see a Datakeeper volume R. It's sitting in available storage. Available storage is the holding spot for all the disks that are currently not being used by a cluster resource. So if I were creating a SQL cluster, I would just run my SQL setup, say create a new cluster, and go through the whole process just like a regular shared storage cluster. At the moment it asks for the cluster disk, it will present the Datakeeper volume R as an available storage location because it's a storage class resource, and Microsoft just accepts it, and it behaves just like a shared storage cluster. I'm not going to walk through that whole process of creating a SQL cluster, but I will show you how to create what we call a Sandless file server cluster. It's going to be a very simple process. Create a new file server, general use file server. Every cluster resource will need a name, file server 420, IP address. And here's the magic here. Select storage. You see that it recognizes the Datakeeper volume R as an available storage location. Say next, next, and finish. And now I have a Sandless file server cluster. You see the name coming online, IP, the volume's already online, and all that was pretty much you know, same experience as you would have with a shared storage cluster. The only other feature I wanted to mention before we open the lines for questions is we also have the ability to do a target side snapshot. So one of the only things that we can't do that always on failover clustering can do is, the always on availability groups will be the readable secondary. So this is a true active passive cluster where SQL Server is running on SIOS 2 at the moment, so SQL on SIOS 1 is offline. What we can do is through our command line interface, we can give you the ability to do a target side snapshot. So at any given time, you can run a command called emcmd take snapshot past the volume letters you want to take a snapshot of, and it'll give you an application consistent point in time snapshot of the data of those volumes on the target server, which you can then access in a read-write fashion. So if you wanted to mount those databases from a different instance of SQL to run some month-end reports, or even just do an X-copy off to some archive storage to supplement your backup plan, that option is available for you. When you're done with the data, you run the command to drop the snap. And this whole process does not interfere with the ongoing real-time replication and the high availability features of the software. So you can do that without impacting any availability. And it's also great for disaster recovery testing. If you want to make sure the data is there, you can run that again without impacting production. So that's another option. So we have about 8 minutes left, so I'm going to stop talking and throw it back to Joey. I think it's there's a slide he's going to throw up, and then Greg's going to start taking your questions. If you haven't submitted any questions, you can do that through the interface, and we'll stay here to the top of the hour if need be and answer your questions.
Okay. All right, we'll go through some questions. Hey, Joey, is there another slide that has just the contact information for SIOS?
Yeah, there is not, actually.
Okay. All right, we'll go through some of these questions. So going back early on in the presentation, there was a question that came in that just related to database as a service. I'm just wondering, what are the benefits of moving to the cloud versus keeping things on premises?
So that's a good question, and database as a service is an interesting level. So database as a service is a challenge because basically, as of right now, you need to recode your applications because generally speaking, both RDS and SQL Azure aren't fully code complete with regular SQL Server. But generally speaking, the benefits of the cloud service or of the cloud in general are you don't have to manage your infrastructure, your data centers anymore, and you can easily have servers in any of 30 plus regions in the world. Whereas now you either have to deal with a colo or some other provider to do that. Frankly, from a cost perspective, it's probably a little bit more expensive. Just if you're comparing what it costs you to have a VM on-prem versus a VM in the cloud. But there's additional layers of data protection. So there's always 3 copies of your data, even though it's transparent to you. And you have the ability to take advantage of other things. A good example of this is one of the things you can do with SQL Server running in a cloud VM is you can check a box and have the updates and backups taken automatically from you with you. You also get flexibility, so it's very easy if you're having seasonal workloads and you have to change. You don't always need a big server, but sometimes you do to take advantage of that. So lots of advantages to cloud. Mainly, it's getting out of the data center business.
Okay, all right, the next question, this one's for you, Dave, is related to, is there any performance hit or latency hit when adding Datakeeper to the equation?
Yeah, with any synchronous replication solution, the way that it works is for any write operation, that write has to be committed on the target server before it's committed on the source server. That's the only way to guarantee the data is always 100% in sync. So there is going to be some amount of overhead associated with any synchronous replication, including whether you're doing always on or Datakeeper. Now, prior to SQL 2016, always-on availability groups had a pretty significant amount of overhead. There was a single process happening that Joey could probably describe better than I could, but we did some testing that showed in a very extreme, to give you an example, a very extreme situation with some Fusion IO cards, the PCIe flash-based storage, we were had a database that was inserting over 1 million inserts per second with no replication in place. With Datakeeper in place, we were still inserting over 900,000 inserts per second. So in that particular case, it was a 12% overhead in an extreme scenario. And with SQL, at the time, I think it was SQL 2012 or 2014, the same test with always-on availability groups had about an 80% overhead. So they had a significant problem. They were only inserting, I think it was like 300,000 rows or thereabouts.
Yeah, so they rewrote that for 2016, but basically the cap, as I recall, is about 400 megaseconds. And you're not going to see any more throughput than that.
Yeah, so Joey, so in 2016, I understand it got better. I haven't gone back and ran that same test, but I assume they're getting better with that. But long story short is, yes, there's going to be some amount of overhead, and it's going to be very much dependent upon the network latency, the disk, right? So let's say you have a super fast disk on your source, but then you cheaped out on your target and just got some regular old storage. Well, guess what? The regular old storage is now your bottleneck because you have to write to that first anyway. So you got to be smart about it and make sure that you're not introducing artificial bottlenecks in the replication process.
All right, the next question, guys, is what does AWS use that's like Datakeeper? And I'm guessing this is for the replication from site to site. I'm not 100% sure.
Yeah. I mean, I'm not aware, Dave. Do they have like any kind of built-in disk replication?
I mean,
locally, yeah.
I mean, Datakeeper does two main things, right?
Yeah.
Replication, and then integration with failover clustering to give you that high availability solution. Now, most cloud providers will give you the option to make sure your storage is geo-redundant and that sort of thing. So there's some, replication going on.
But and I didn't know specifically on AWS side, but I know on Azure side, the geo-redundant storage isn't transactionally consistent. So it's not something you can use for database servers. Basically, the common scenario, at least on the Azure side, is we'll use local storage for the databases, and then if we have those needs, we'll do backups to a geo-redundant volume.
There you go. Yeah, so I don't. There's nothing in AWS specifically that will do what Datakeeper does.
Okay. The next question, Dave, is just related to how is the Datakeeper product licensed? Is it per machine, per instance? How does that work?
Yeah, it's per instance, per machine, however you want to spin it. Basically, each server that's participating in the replication is going to need a license. So it's licensed per server.
Okay. Another question, I guess this might be for you, Joey, is what challenges do you see when trying to administer disaster recovery for databases that are like terabyte levels when they're in the cloud?
Pretty much the same that's on-prem. So just making sure things are consistent. Recovery time. So when you have a DR incident, how long does it take the database to come back online? So making sure your storage is fast enough so the recovery is quick. In general, I think it's a little bit easier. I'd actually say in the cloud because you're more in control of your network and storage, whereas like typically on-prem you're less in control of those sorts of things. So in some ways it's even a little bit easier.
All right, well, we're just about out of time, so we're going to just wrap things up. So thank you, Joey, and thank you, Dave, for sharing that information today. And I also want to thank SIOS for sponsoring today's event. The webcast was recorded, and you'll receive a follow-up email with links to view the archive, and we'll also put the slides out there that you can download as well. Also, please visit MSSQLtips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MSSQL Tips. Thank you for attending and have a great day.